Hello everyone, welcome to the class. Today we are going to start with the second part of this chapter named Atoms and Molecules. Last time we have learned about the philosophical aspect of atom, then we have learned about the law of chemical combination. Under the law of chemical combination, we have learned two basic laws. One was law of constant proportion and other was law of conservation of mass, which was given by father of modern chemistry, Antony Lavoisier. In today's session, we are going to start with the next thing, that is Dalton's theory. Why we are learning this Dalton's theory, how this Dalton's theory was very important for us, and what are the postulates of this Dalton's theory, that will be the topic of the day. So let's start with the Dalton's atomic theory. British chemist, that is John Dalton, provided the basic theory about the nature of matter. Dalton picked up the idea of a divisibility of matter, which was till then just a philosophy, which we have learned already in the previous session. Because most of the evidence, most of the things were philosophical, as there were not much evidence was available, not much practical information was available by then, and that's why we are saying it was just a philosophy. But Dalton picked up the same idea to prove the theory. His theory was based on the law of chemical combination, and everyone knows that there are two laws of chemical combination. One is your law of conservation of mass, and another is your law of definite proportion. Yeah. So according to the Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particle called atom, and that is nothing but the very first postulate of your Dalton's atomic theory. What is this particular postulate of this Dalton's atomic theory? All matter is made up of very tiny particles called atoms, which participate in the chemical reaction. If you see anything around you, okay, so that is made up of small particle which we called atoms. As you see in front of you, I'm showing you the golden ring, and if you see the golden ring, that is also made up of small tiny particles which we called atom. If you try to see the atoms with your naked eyes, it's not possible at all. You need to know that. That's the very first postulate, and it's not hard to understand. Okay, going further, in a postulate number 2, he's saying that atoms are indivisible. Means what? You can't break down that last part which we called atom. Okay, but apparently we proved that atoms are divisible. They are divisible into protons, neutrons, and electrons. Means what? Is this postulate true? Absolutely not, right? And that's why it becomes the drawback of the Dalton's theory. And drawback is what? No, atom is not indivisible, whereas it is subdivided into electron, protons, and electrons. About electron, protons, and neutrons in detail, we are going to learn in the next chapter. Going further, in a postulate number 3, he is saying that atoms of given elements are identical in mass and chemical properties. Here you need to focus on some important words, that is for a given element, right? For a same element he is talking about. He is saying for a same element, if you check their masses and their chemical properties, each and every time it will be same. But we know that there are few elements like carbon, hydrogen, chlorine, where they have same atomic number. Means obviously they belongs to same family, they are same element, but their masses are not same. Hence hence we prove that this postulate also not correct one, right? Because if you see here, number of protons are same, that is your atomic number, right? Everywhere, in case of your carbon, in case of your hydrogen, and in case of your chlorine, every time your number of protons are same, but the number of protons and neutrons which consist the mass of an atom are not same. Means postulate number 3 is not correct. That's why it becomes the drawback. And the drawback is what? No, not every time for the given element you're going to have same mass and same chemical properties, right? And whenever you have same atomic number but different mass number, that thing we call isotopes. We will learn about isotopes in detail later. Going further, we are going to have postulate number 4, that is atoms of different elements have different masses and chemical properties. Again, you need to focus on few words here, that is your different element. Here we are talking about different elements. In previous postulate we were talking about for the same element. Now we are talking about different elements. So whenever you see different element, he said that for different elements their masses needs to be different and automatically their chemical property will be different. But is that true? The answer is no. For different elements, like you have argon, potassium, calcium, they are having same mass number. Obviously their atomic numbers are different because they are different elements, right? But their mass number will be same. In this case, we are saying no, this postulate is also wrong, and that's why it become a drawback, right? So whenever you have different atomic number but same mass number, what you call? We call that is nothing but the isobars. So here potassium, argon and calcium are isobars of each other. Okay. Going further, we have a postulate number 5. Atoms combine in the ratio of simple whole number ratio to form compounds. Here you need to understand what is the meaning of simple whole number ratio. Before talking about simple whole number ratio, you need to understand what is a whole number ratio. If I give you example like C12, H22, O11, in this case you have 12 carbons, 22 hydrogens and 11 oxygen, right? So in this case you have 12 is to 22 is to 11, but in other case you have C6, H12, O6. In this particular case the ratio will be 6 is to 12 is to 6 for carbon is to hydrogen is to oxygen, right? So here if you try to check, can we divide it further? In one case, yes, you can do that, which is 1 is to 2 is to 1 here. But in this case of your C12H22O11, you can't do that, and that's why we call this is the whole number ratio. Okay, this is the whole number ratio where you can't divide it further. But in the glucose case, you can divide it further. That's why we call it a simple whole number ratio. This is your whole number ratio and this is your simple whole number ratio. I hope you got the difference between whole number ratio and simple whole number ratio. But is this true? He said every time, each and every time you are going to have simple whole number ratio in all the compounds. The answer is no. Every time it's not correct, because just now we have proven that in our first example you are not going to get simple whole number ratio. It will be just whole number ratio, right? And that's why it is also your drawback. And what we are saying in the drawback, different atoms of different elements do not have simple whole number ratio. That is a postulate number 5 with its drawback. And last postulate, that is postulate number 6, the relative number and kinds of atoms are constant in the given compound. This is nothing but the your law of constant proportion, where all the elements are combined in the fixed ratio to form particular compound, right? If I take example of water, so in this case every time your 2 hydrogen and 1 oxygen will combine together, right? And you will get water. If you take another example like sulfuric acid, in this case also hydrogen is to sulfur is to oxygen will be your 2 is to 1 is to 4. You take any example, every time when you say the formula for that particular compound, every time they will all the elements will combine in the fixed ratio. Okay, so what do you think? Is this law correct? Absolutely. Not law, sorry, postulate. Is this postulate correct? Absolutely. This postulate is correct, and that's why we are not saying any drawback for this. So I hope you understood that out of 6 postulates, the 4 postulates are having drawbacks. Only the first postulate and the last postulate is correct. Okay, I hope you are clear with the 6 postulates of the Daltons. So let's try to solve some question on the basis of that. So very first question is there in front of you, that is, according to Dalton's atomic theory, matter consists of indivisible molecule, atoms, ions and mixture. You can pause the video and you can answer in the chat box. I hope you have answered already. So according to Dalton's atomic theory, matter consists of indivisible atoms. Correct? So that's why your answer will be option number B. Question number 2 is you have, according to Dalton's theory, atoms of different element differ in mass. Is this true statement? You need to think about Dalton's theory. So yes, he said that for the different element mass will be different, but we have proven that no, that's not true. Okay, but the answer for this question is true. According to Dalton's theory, the answer is true. Yeah, he said that, correct. But we have proven that this statement is wrong because there are isobars which are having different atomic number but same mass number. Okay, going to the next question now, which is the last question of this particular class. Which postulate explain the law of constant proportion? You can again pause the video and try to answer this. I hope you have answered. And the answer is your, the relative number and the kind of atoms are constant in the given compound, which is nothing but the postulate number 6. Every time you are going to get a particular compound in the fixed ratio of their elements. Yeah. And thanks for joining again. I'll see you with the next part in next class. Till then, take care. Goodbye.